These are different than Alex, so I want to use this for Alex, but like I use it. They're similar. I think the one in Alex is easier.
And then OCS, that's like how many so that's 6. 6, 5, 12, 18. 18. So
I see some people working on this, so I'm going to give you a minute to go over it.
I think it would be a thing. You don't need to be that one. It would be a thing. Go wash your pen. Instead of just trying to mind. Because you have to control you know, also like don't leave it too much on that stuff.
All right, are you ready? You want a minute? What do you want to do? You ready? Okay. So we have NaOCl. This one is a kind of weird one. We're going to put the nitrogen in the middle. If we look at the electronegativities, nitrogen has the least electronegative atom, so it's going to be able to share its electrons easier. Chlorine is going to pull all the electrons towards itself. Oxygen is going to pull all its electrons. So nitrogen is going to be in the middle, and then we'll attach oxygen and chlorine. Okay. So then, how many electrons did you calculate we need here? 18. Okay, so we've shown 4 so far, so we've got 14 left. We'll start by putting them around the outer atoms. So now we have, out of 12 more, we have 2 left. Where should we put them? 2 on the end. Okay, now what should we do? Nitrogen doesn't have enough electrons, so one of these atoms needs to share. Which one is going to share?
The oxygen.
Oxygen's going to share because it's less electronegative than chlorine. And usually oxygen likes to make 2 bonds. Chlorine likes to make 1 bond. So we're going to do something like this. Double bond from oxygen to nitrogen, lone pair on nitrogen, and then chlorine. Okay. Just for fun, what would the electron geometry be? We have 3 different groups. Yep.
Oh yeah.
So this would be trigonoplanar if we're looking at the electron geometry. What would it be called if you're looking at the molecular geometry? Yeah, this would be bent because we would ignore the lone pair. We have 2 groups that's bent. Okay, the electron geometry will be on the final, and the Lewis structure. Lewis structure will be on. Okay, let's look at our schedule really quick, and then I have a request for you. Next Wednesday during your class, I have my teacher observation. So I'm going to give you a heads up now. They do look at how you are acting. So usually I just kind of let you do whatever you want. But just keep in mind that they grade me on what you're doing. So especially for that day, just kind of, it would help me out a lot if you were on task. Okay, so that's next Wednesday. All right, questions about that? Okay, all right, thanks. We're gonna do chapter 2 day of notes. We're on Thursday, and then we'll have 2 more days of chapter 5. Remember, keep going through chapter 5 as we're going through chapter 5. There are 6 students who haven't started chapter 5. Okay, that makes me nervous because it's hard. It all builds on itself, and if you get stuck at the end, you're not gonna have enough time. If you start like Sunday the 20th, if you start on that day, you might not get finished, okay, by the deadline. So make sure that you are completing the assignment as you go. Okay. All right, lab 4, if you haven't turned that in, is due next Wednesday, so make sure you do that. And then our next lab is lab 6. So get ready for lab 6 by doing your pre-lab. Questions about our schedule? Okay. Let me pull up our guide. Okay, we are going to talk about these things. We're going to talk about molar mass, Avogadro's number, and then converting. And if we have extra time, we have a lot of extra time, we'll do oxidation and reduction. We probably won't get to that. We already talked about this. We're going to skip this. We talked about this last time. Okay, the first thing we're going to talk about is the mole. The mole is a conversion factor. 1 mole is 6.02 times 10 to the 23rd things. Okay, this is confusing sometimes because we have scientific notation, we have this weird number. But if I just think of 1 dozen is 12, 1 mole is 6.02 times 10 to the 23rd. It's the same thing. Okay, so just think, if it's like overwhelming, if it doesn't make sense, just go back. Oh, I know what a dozen. 1 dozen is 12. 1 mole is the same thing. Okay, it's just a conversion factor. We use this in chemistry because we are dealing with large amounts of things. If you think about like a spoon of, like, what did we use last time? Iron nitrate, I think that we used that one, I think. If you scoop up a scoop of that, you're dealing with on the order of times 10 to the 23rd iron atoms, or nitrate ions. So we need a number to make sure we're not always using scientific notation. So this just makes our numbers nicer. Okay. Chemists usually use moles, and this is how we convert to moles. Okay. Yes, Bill?
So it's the number of
things. So like a dozen is 12 things. You could have a dozen shoes. I could have a mole of shoes, but I have way more shoes than a dozen. Does that make sense? Okay. It's just a number of things. Yeah, just like a dozen. Okay, we're gonna watch this video. All right, I like that idea. Okay, so the mole is just a conversion factor. You don't need to write this. This is just to show you that this is like a conversion factor. Like if we have 1 foot, we also have 12 inches, and we can write that 12 feet or 12 inches over 1 foot, or 1 foot over 12 inches. Okay, so we can write 1 mole for 6.02 times 10 to the 23rd atoms, or 1 mole for 6.02 times 10 to the 23rd atoms, depending on how we need that. Okay. I also want to point out on here that mole is abbreviated MOL. Molecule, we don't abbreviate. So don't get that confused. If you're working with molecules, don't truncate it, don't abbreviate it. Write out molecules. Okay. Or you might get confused. So mole is MOL, that's the one we use MOL. Okay. Questions on that? So you don't need to write this down. This is just so you can see, like, you can use it as a conversion factor. You can flip it upside down. So 1 mole is 6.02 times 10 to the 23rd atoms, or 6.02 times 10 to the 23rd atoms is a mole. Okay, so depending on how you need it in your equation. I have a few conversion charts in here. If you want me to print these out, I can do that, so just let me know. Or you can copy them from the slides. You use these when you're converting from mass to moles to mass. If you're doing that, if you're going from mass to moles, you're going to divide by this conversion factor. If you're going from moles to one of these units, then you're going to multiply by the conversion factor listed. Okay. So for example, if I have the mass of something and I need the moles of something, I'm going to divide by the molar mass, and we're going to talk about what that means in a minute. If I have the number of particles, I'm going to divide by Avogadro's number to get moles. If I have moles and I want to get to particles, I'm going to multiply by Avogadro's number. Okay. So these charts can help you set up a conversion equation. The other way, so what I do is I just set up my equation, figure out what unit I need, and then just make sure that it cancels out. Okay. But if this is going to help you, I can print these out for you. So let me know. Okay, and I just have a few of them in here. Let's see, where's the mouse? Okay, so let's look at an example. This one, we have 1 mole of carbon. So how many atoms is that?
6.02 times 10.
Yes, good. So 1 mole is 6.02 times 10 to the 23rd. Let's see. And we could set up a conversion factor for this. Oops. We could start, so this is what we're starting with, 1 mole. And we want to end up with how many atoms? So if I start with 1 mole of carbon, I need a conversion factor to get me from moles to atoms. So I'm going to put up what I want to end up with, my unit over here. And I just write what I started with. And then I need a conversion factor. So this is going to tell me what needs to go on the top of my conversion factor. I need atoms to go on the top. And this is telling me what I need to cancel out. Moles need to go on the bottom so it will cancel. And then my conversion factor is, for 1 mole, my ponytail is falling out. 1 mole is 6.02 times 10 to the 23rd atoms. So moles of carbon cancels out, I'll end up with atoms. So 1 mole is 6.02 times 10 to the 23rd atoms. Okay, questions on that? Okay, what if we have 2 moles of carbon? Yeah. Times it by 2. Good. Good. So we just times that by 2. I'm just going to put this up here. So 2 moles of carbon, we have 6.02 times 10 to the 23rd times 2. Moles cancels out, we end up with atoms. So you can either use a conversion chart to help you. So if we're going from moles to atoms, we need to multiply by Avogadro's number. Or what I like to do, this helps me on a lot of my different, this is called just like our unit conversions. This helps me know which ones to cancel out and which direction I need to put the conversion factor. Okay, go ahead and try the second question. See if you can figure out the second question. Let me do the second.
So you start out with 6.7 moles of AgNO. And convert it to molecules. Okay. So you do you need to do times those moles by we're not going down, we're going to take a slightly. Yeah.
All right, how are we doing out there? Are you ready to start? Okay, so how do we set this up? Where were we starting? Good, we're starting with 6.7, and we have moles. Okay, moles of AgNO3. I'm gonna write that. Okay, and then I know I need a conversion factor. And what are we trying to figure out at the end? We're trying to figure out how many formula units. So that's just how many, basically how many molecules, but it's an ionic compound.
That's something it didn't say.
Oh. Okay, so what needs to go on the bottom of our conversion factor? 1 mole. Good. So one always goes with mole for Avogadro's number. So 1 mole, and then the mole goes on the top. 6.02 times 10 to the 23rd. Oops. Mole. Not formula units. Okay. So moles cancels. Moles of AgNO3. Then we'll end up with formula units. So this is a good chance to make sure that your calculator does this right. Okay. Alex has a calculator and it's pretty helpful on these types of problems. So you can also use that. So I'm going to do 6.7 times 6.02. And then instead of putting times 10, I do the second capital E button, 23. So I'll write how I type that. So this is what I'm putting in my calculator. 6.7 times 10 E, oops, wrong. Times, there we go. Times this number, 6.02, capital E, 23. So on your calculator, the capital E button is the same as times 10 to the. So that is, I use that as a shortcut. So just make sure that you know how to do this on your calculator. If you're doing this in Alex, you have to watch out for sig figs. There's 2 sig figs here, so I need to end up with 2 sig figs. So I got 4.0 times 10 to the 24 formula units of silver nitrate. Questions on that?
No.
Yes, Eliza.
So do we just use like the sig figs from the like how?
Yes. Yes. Yep. Remember, conversion factors don't count towards your sig figs. Yes. Okay. Other questions? Okay. Let us keep moving.
I don't know.
Oh yeah, still.
So sometimes you use like additional subtraction. No, I said it.
Yep.
But you use
Oh.
a multiplication rule.
You what? Can you give us an example of where you use both?
Like so, in like it asks like chemical reactions
Okay.
between like boron and oxygen, and then you like add those two more masses together. First, and then you like do the multiplication between.
So the molar mass, I think it tells you to keep like 2 beyond how many you actually need, or like through 2 beyond what you actually need. Is that okay?
Yeah.
Okay. I just always type it all the way out, and then I know I can see.
Okay.
But yeah, I think that's what Alex says. Okay, so this is going backwards. See if you can set this one up. How many moles is 5.6 times 10 to the 29 pieces of sand? See if you can go backwards from things to moles. Okay, I see those people comparing numbers. What numbers are you guys getting? Should we go through it? So we have this number. We always start with our given value. This is the given value. We're just going to start with that. So 5.6 times 10 to the 29 pieces of sand. We know we need a conversion factor. What are we trying to end up with? What does it ask for? Moles. Moles of sand. Okay. Moles. How many moles? That's what we're trying to end up with. So in our conversion factor, what needs to go on the top? 1 mole. And then this number needs to go on the bottom. 6.02 times 10 to the 23rd pieces. Okay. Then pieces will cancel. Okay. Check on your calculator. Look, we have this big number divided by a smaller exponent, but it's still big. This should be going down. Our exponent needs to be going down. Does that make sense? Because remember, if we have like x cubed over x squared, this will subtract. So our exponent should be going down here. Okay? So be really careful. If you don't put it in parentheses, then it will give you the wrong answer. What's going to happen is your calculator will do this. It'll do divide by 6.02, and then it'll pop this back up to the top, and you'll get a really huge exponent. So this exponent should be going down. So watch out for that. One way to avoid this is to type it in with the e. You do 5.6 e29 divide by 6.02 e23, and then that will. You don't have to put parentheses around that. Okay. So 5.6 second capital E 29 divided by 6.02 second E 23.
So we can just do the top.
Yeah. Yeah. If you're putting it in with the times 10 to the, you have to put parentheses around it. If you do E, your calculator automatically knows that that is one number. Otherwise, it's following order of operations. And it's doing divide, then multiply everything by that second part. Okay. Okay, so this is what I got. We'll see if you got the same thing. I got 9.3. I need 2 decimal places. 9.3 times 10 to the 5 moles of sand.
So it's not like if in a non-scientific notation, the line is 30,000.
Yeah. Okay, but in Alex, you're gonna have to type in with the corrections. Yes. Yep, you're right though. Yep. Okay. Do you want to try the next one?
Yeah.
Okay. Did you already do that one?
Yeah.
Okay, I'll give you a minute. Go ahead and try the next one. This is a good time to check your calculating skills. Make sure you are comfortable with your calculator.
That's MOL does not stand for multiples. Okay. So it is. Yeah, it is. Yes. You did modules would be this. That's right.
Are we doing okay?
Yeah.
Ready? Okay. So no? Yes? Okay, I'll give you a minute.
Yes. Oh wait, no, you don't.
Okay, let's go ahead and do this one. So we always start with that given number. This is the number we're going to start with. So 7.23 times 10 to the 24, and that's molecules. Okay, and then we're trying to convert this, so we need a conversion factor. We're trying to convert to what? Still moles, okay, good. And that tells me 1 mole needs to go on the top. If it's on the top over here, it needs to be on the top of my conversion factor. And then molecules is here, I need to cancel out molecules. So 1 mole for 6.02 times 10 to the 23rd molecules. Okay. If you're getting confused by this, just remember, like, this is like 1 dozen is 12. 1 mole is that many things. Okay. And then what did you guys get here? Just got 12? Okay, and then how many sig figs?
2.
So we have 3 here, so we need 3 here. So it'll be 12.0. But that would be a 4 sig figs, so we just need 1 decimal place.
Oh my god.
Okay, questions? Are you alright? Is that making sense? Okay, very good. The next thing that we need to talk about is another conversion factor. This is called the formula weight or the molecular weight. If we're talking about ionic compounds, it's called the formula weight. If we're talking about molecular compounds, it's called the molecular weight. And all we do is we add up the number of atoms in the formula. This is pretty straightforward. And our units are either in atomic mass units, AMU, or they're in grams per mole. This tells us how many moles are in, or how many grams for 1 mole of that substance. So this is like, if you, like the video was talking about going to the deli and ordering 43 slices, you don't do that. You figure out about how many pounds is 43 slices, and you order your meat by the pound. That's the same thing. We can't measure out moles. We need something that we can measure, which is grams. So we just figure out how many moles do we need, and relate that to the mass that we can weigh. Okay. So this is just another conversion factor. This one's pretty straightforward. So do you remember, I don't know if you talked about this actually, do you know where to find the atomic weight of each atom? Yep, on our periodic table, good. So the little number that has like decimals, that's the atomic weight. So each atom tells you how many grams you would need to weigh out to get 1 mole.
Oh, so that converts to 1 mole.
That's like that number on there. So like oxygen is like 15.9999 grams for 1 mole.
Okay.
So if I have 15.99 grams of oxygen atoms, I would have 1 mole of oxygen atoms. Okay. Okay, so here's an example. If we were trying to calculate the formula weight for iron sulfate, we have 1 iron, that is 55.85. Periodic table is rounded differently, so you should just always use the Alex one when you're doing the Alex homework. So just keep that in mind, but the number is coming from the periodic table. Okay, 1 sulfur, we've got 1 sulfur in there, and we've got 4 oxygens. We just add up the atomic mass weights, or the atomic mass unit for each atom, and that gives us the formula weight. This is either in atomic mass units, or we can also say for 1 mole, I need 151.92 grams for a mole of iron sulfate. Okay. All right, so I want to show you this cool tool in the Alex program. Let's see if we can find this question. Chapter 5. So this is called finding the molar mass from chemical formula. So it'll say something like this: the chemical formula for this, calculate the molar mass of, this is called urea. So we go over to our calculator in Alex. This is pretty handy. And then I just type in this, click on this A, and then I can type it in to my calculator. So how many nitrogens in this compound?
2.
2. So I go 2 times nitrogen. And then plus, how many hydrogens? 4 times, times hydrogen. Plus, I have 1 carbon plus oxygen. Enter. So this is the molar mass, the formula weight for urea. Okay, come on. Oh my gosh. Anyways, you can copy paste this, and it'll tell you how many decimal places to use. So this one says 2, so I'm just gonna go over here. And if I can see it right, I'm gonna delete these ones and then submit. Does that make sense? So that's pretty slick. Okay, if you're doing a lab, this is how I find the molar mass. Molar mass for urea. And that's pretty close, but can you see Alex's rounding is slightly different than what I'm using. If you're actually making a solution, it doesn't matter. But if you're doing Alex homework, it does matter. So just be careful about that. This is good enough for any lab that we do. Okay. Alex just rounds differently on their table. The other way you can do this is you can do it on your own calculator. So you can just do the same thing, the atomic mass is listed here. Okay. It's in Daltons. This is the same thing, but we can switch the units to grams per mole or atomic mass units. Okay. Questions on that? Okay. So go ahead and I'll just give you like 1 minute. So pick one of these, see if you can find the molar mass. You can use the Alex calculator, you can use this periodic table, whatever. Just practice, make sure you know how to find the molar mass, the molecular weight.
Yes.
I like caught it like right in my hand too.
What are we doing? I hope that you don't do this next one.
We're just getting it out now. So
Okay, we're getting it out now so that. Okay, well, if she shows up to observe you, you'll have to stop. Okay.
Oh,
they've tried to get out there. He's got like, it's just the same almost.
oh, well, I mean, it's probably different from what's in there.
Not just in the box.
Okay, have we had enough time to do one? Or did you pick one? Okay, I'm just gonna show you. Do you understand the process or do you wanna go through one again?
Just one.
One more? Okay, tell us which one. Which one did you do? Which one did you want to The last one? Okay, so we're gonna add up zinc plus how many nitrogens? 2 nitrogens plus good and 6 times oxygen. Okay, so then we just need to look this up. Remember, if you're doing Alex homework, you really need to use the Alex periodic table. But if you're just doing this for a lab or just for just like notes, you can just look it up here. So zinc on this periodic table is rounded to 65.38 plus 2 times nitrogen here is 14.007. I'm just looking at the number here. Plus 6 times oxygen, which is 12.011. Okay, and these are slightly different depending on which periodic table you use. If you're really doing a lab, it doesn't matter. If you're doing Alex homework, Alex cares, so watch out for that. Which is kind of dumb, but I don't know how else they would read it. Okay, did anyone do this one? Okay. All right, and then Alex is always going to tell you how many decimal places to report. This one only ended up with 2, so I'm just going to list 2. And then our units, this is going to be grams per mole. So this is telling me for 1 mole of zinc nitrate, I need this many grams, 165.46. Yes? Oh, I did. Thank you. Good catch. So let's go back and fix that. Good catch. I'm impressed that you knew that was carbon. So this is also nice. Oh, not white. So oxygen is 15.99. You can usually round this up to 6. Yep. And 16 is good enough for a lab. Okay, there we go. 15. Okay, there we go. So 189.388 grams per mole. Okay, questions on that? Does that make sense? Okay, the answers are in the slide if you need to check and see. You can also check my work. Maybe I got this wrong last year. Okay. So molar mass is a conversion factor. If we have moles and we need to get to grams, we can use that conversion factor for that compound. If we need to go the other way, if we have grams, we need to get to moles. I don't know what I said first, but we can get to that conversion from using our molar mass. So for example, here we have 4.5 moles. So I'm going to start with that. I just write down my given value, 4.5 moles of calcium hydroxide, okay? And I know I'm going to convert from moles to grams. So I need to end up with grams, okay? So what units will be on my conversion factor. What needs to go on the top? What needs to go on the bottom? So grams is going to go on the top. I need to end up with grams. So grams is going to go on the top. And I need to cancel out moles. So there's a moles on the top. I need to put moles on the bottom so it will cancel. Okay. So 1 mole, I need to figure out how many grams. And this was on this previous slide. Oops, wrong direction. So this is the molar mass for calcium hydroxide. It's 74.092. So I'm going to put 74.092. So that's just what we did. We added 1 calcium, 2 oxygens, 2 hydrogens. We got this many grams for 1 mole of calcium hydroxide. Okay. Moles of calcium hydroxide cancels, and we end up with grams of calcium hydroxide. And then all we're going to do is 4.5 times the molar mass. Okay, and so then I end up with, I'm just going to write this, 333 grams. Okay, question?
So when I was using the calculator I'm on this topic right now,
Uh-huh.
and for some reason the unit is grams times mole to the negative.
Okay. Yep, that's the same unit. So grams times moles minus 1. So this is just if you have a negative exponent, it goes to the bottom.
But so I thought that moles would cancel out of grams.
Is it asking you, this is the unit for molar mass. Is it asking you for the molar mass? Okay, yeah, that's the unit for molar mass, grams per mole. Okay, good question. All right, I want you to try one of these. Try one of these. We're going from moles to grams. So we need to calculate the molar mass, or you can look it up on the internet.
Well, because it takes probably the best shower. I just say watch it. Yes, I would. So, grams is.
And this probably, you say you could get us like a conversion chart for
Yeah,
like,
if you want one. Do you want one? Do you guys want that?
I would like. one.
Yeah.
Okay. Okay, I will print some off. All right, are we ready to do one together? Not yet. Okay.
Did you finish that Alex? I know we were doing it, Anderson? No? I started doing that, I was like, I need help. Oh, no. You just moved like 3 points, that's my math.
Yeah. So nice. So is the like that's all those constructs but then times age yeah. You look at me right out like okay, so then however number 2 times 2, right?
Four fit on the page. How many of us are there? 3. Okay. 3 people.
No, there's 10. Yeah.
What?
Also, one's not there. Oh, yeah, one.
And there's then there's it's one of those things where the lines is in your brain. It's one of those things where I'm just like out of it. I'm getting myself.
So you're physically here, but like.
I don't know.
Okay, I printed those off, so I'll get them to you. Let's look at the first one. So we're gonna start here. We always start with the given value. We have 3.7 moles of this thing, C2H4O. Okay, we need a conversion factor, and what are we trying to get to?
Grams.
Grams, good. Okay, so we can either Google this. So Alex, we can't Google it, but we could Google this. We could add 2 carbons, 4 hydrogens, 1 oxygen. Did anyone get this conversion factor? You don't have it? Okay, we can look at that one. Oh, you got it? Wait, I didn't write it down. You didn't write it down? Okay.
I think it's like 44.05.
Yeah.
Okay, you guys are good at remembering numbers. 44.05. How do I know that this goes on the top? Yeah, the number always goes with grams. 1 always goes with moles. So then moles cancels. It's supposed to be moles. Then you multiply through. What do you end up with over here? 3.7 times 44. Okay, and we need 2 sig figs. So this is one of those weird ones where you're gonna have to go. You're gonna have to change it to something like this. So you got to move the decimal place. You only want 2 sig figs. Yes.
So we're just doing moles times the molar mass.
Yep. Moles times the molar mass.
And if you just want molar mass, it's just 45.
Molar mass is 45 or 44 grams per mole.
Oh yeah.
Yep. Okay. Does that make sense? Do you want to do another one? What do you guys think? We're good, or do you want? What does that mean?
Oh, I'm good.
You're good. Okay. Okay. There are a few more in here if you want to look at the answer. The other way we can use the molar mass is to go the other way. So we just went from moles to grams. We can go from grams to moles. Okay. So this one, if we have this many grams of this is phosphoric acid, we need a conversion factor to end up with number of moles of phosphoric acid.
It's 16.7 grams.
Oh, thank you. It's a long day. Okay, thanks for catching those errors. I appreciate that. Okay, so we just need the molar mass. We need something that has moles. Moles needs to go on the top because I end up with moles. So for 1 mole, I need to know how many grams of phosphoric acid. Okay, so I would calculate this. I need 3 hydrogens, 1 phosphorus, and 4 oxygens. So I'm just going to do really lazy. So I have 3 hydrogens, so 3 times 1 plus phosphorus is 31-ish, plus 4 times oxygen is about 16. So the molar mass here is about, this is not good enough for Alex, but it's good enough for our example. Okay, so this is our molar mass for phosphoric acid, 98 grams per 1 mole. Okay. Our grams of phosphoric acid will cancel, we'll end up with moles, that's what we want. And we'll do 67 divided by 98. That gives me 0.68 moles of phosphoric acid. So we're just doing more conversions. This is all conversions, just with new conversion factors, molar mass and Avogadro number. Okay, questions on that? If you get really good at conversions, classes like if you take thermodynamics or physical chemistry in college, you do a lot of unit conversions. So, or like physics. Physics is a lot of just making sure you're keeping track of your units. So if you're good at this is called dimensional analysis. This can help you in a lot of science classes. Just making sure stuff cancels out. Okay, do you guys want to try one of these?
Yeah.
Okay, go ahead and try maybe the first one. We'll do the first one together. Okay, while you do that, I'll go pick up my copies.
That's the ability. It is the ability that you relate to. He is Mr. Thank you. You ever be just like sit down in the shower and see what I like sat down to shower. This is very incredible. And then I stood up and then I actually almost passed out in the shower. Because of how I felt like getting water lines. Yeah. So if I
I don't know.
What's wrong? C I stinks. Hall.
I mean, maybe it was, I'm just.
What'd you get on the first one? I haven't done it. I'll do the first one. I'm not gonna do that. I saw 20.
All right, how is this going? Are you ready or do you need a minute? Ready? Not ready.
Not ready.
Not ready. Okay, so it's like.
Surely one of that.
Surely you're not. No. I never said that. What you did? We're both stupid. I didn't practice. No, I know how to do it. I did it until. Right? Last one does. That's not true.
Okay, how are we doing now? Ready? Okay, here we go. Where are the? Okay, should we do this top one? So we have this many. We have 312 grams of this compound, and we need to convert to how many moles? Okay. So, how will we put our conversion factor here? What will go on the top?
1 more.
Good, 1 mole goes on the top. Oops, 1 mole. Good. And then did you guys figure out the formula weight for this?
365.
365 grams for 1 mole of this. Okay, and then we just cancel out. Grams cancels. Always check your units. Make sure they're gonna end up correct. And then we have 312. Okay, you probably did this. What did you end up with?
0.85.
Okay, and did you have one more decimal place? Okay.
Round to 5.
So can you see how, oh, round to 5? Okay, we need 3 sig figs. They gave us 3 sig figs, so we should type in 3 sig figs. Okay. All right, does that make sense? You guys feel pretty good about that? Do you want to do one more, or do you want the rest of the time for Alex? What?
That's Alex.
Okay, let's do that. We don't have a lot of time left, so we're gonna stop here. How much time is that? We've got 11. We have 14 minutes left. Don't forget about lab 4. If you haven't turned in lab 4, please turn in lab 4.
I want to know.
Let me see. Where did you get?
Yeah, it's 15 divided by the other one. 162.1. Or do it the other way around. Moles, I think, I don't think 108 moles.
I'm giving you 2 conversion charts. You can't use these on the test unless you put them on your own. You don't have to.
Oh, okay, I read that as 180. Yeah.
Phil, did you see this is 108? It's 10.
That was 108, bro.
10.8.
That was 108.
This is not 108.
I swear it was.
This is 10.8. Is that correct?
Yep, there's one.
Okay, I'll do it the other way. 15 divided by 162.
This one goes like, if you're going out, you go to 1, like 95.
Oh yeah, you were correct. You were correct. You were correct. It was just.
And then if you want to use
I switched it around.
we have about 11 minutes left in the class.
Oh, you see the little dog.
You want to do
You see the little dog.
There we're
I don't even know what this is.
yeah, what do we do that? Yeah, let's do it together.
Like I know who I am, but I don't know what
I don't know.
I'm like, this is a biology person. Yeah.
Which is not.
So they do that as
You usually get like 7 to 8. 7 to 8. Oh yeah, that's not too good.
I don't like
What's that?
gross.
I don't like this. I don't like myself. I sure try but the rest of
What do you do? What did you do?
Questions here?
Probably you did not.
No.
Are you guys in here?
Yep.
He said, no.
Questions over here? And I have
We said no.
So this. Something's
Louis said no.
Wait.
No.
That's like that's
Yeah, it's good on Alex. Like Alex or
Alright, so let's do,
just your question.
I still have
All right, I mean, put that one off.
Please do, please do.
I love this. I love
It's stuck. What? It's not even about. Bro, you're so dumb. Oh my god. Did you read this one? I can't figure it You just know. Okay. What? Can you open this?
Wait, let me finish my sentence.
Okay, so we should do magical topics. If you have the same topic, it's gonna be. I mean, I don't know if I have that open. No, I don't know. I mean, you the one you
I
have.
was just about to say that. Like, I feel like, personally, I feel like they're actually. Yeah. But like, I don't know, I feel like. My sister doesn't, she only has to walk in once a week. Cause they're very like fruits and like yeah. I love like no, they're so yeah, that's and like, I don't know, I just feel like, cause my sister was like, oh, just Christian.
And we need
It's really try it, but like, just doesn't work. And I think it's yourself, like, genetics.
Just that.
It's, but my hair grows really fast. It's just, I feel like that's so easy. Really?
Oh.
No, my hair, and like a year, okay, I cut it in 9th grade, I was to my shoulders.
Alright, so yeah, you sweet. What? No. No.
I thought you guys.
No. You are crazy. No.
I have to finish my friends.
Okay, so it's on 3
We'll have to. There's like a, you know those like posters for the board back in the 20s? Yeah, we have to do one of those.
Want to hear my favorite joke about the
Is that true?
What are your my favorite joke about the
What is it?
Stop him. We're going insane.
What are my favorite joke about
Okay, so right then.
So we're saying it's like.
So I wrote this down, so I have it. Got right down there.
Wait, Phil,
Okay,
okay,
so I wrote that down, right?
no one's at Abbey like.
Okay, so I wrote that down now.
I know I didn't do any of the topics for this chapter, but it says I might have tracked down. You gotta hear.
So
That's fine.
Okay, so we want mold right here.
All I was thinking was something.
What are the?
Oh, so if we want to hold there, we want that one. Or no.
No, literally, I hate that because like do all the easy ones, or like all the ones that are like three. Yeah.
What's it called?
And then like and just small, and then you go on to do all topics.
Bottom on the top.
For example, that's not
Yeah.
Questions?
Okay, writing the yes.
I'm doing
So Valentine's
not
Day.
Oh,
Yes. Oh, I'm getting.
Oh.
yeah, I'm doing that like.
Over this one.
Okay, so
I
then
have
here,
four. Every year.
then over